carefully, okay? In regression, most of the time, outlier in y direction is not inferential. You see what? Outlier in x direction is inferential. Say people give you a data set, x1, y1 up to xn, yn. You make what? Scalar plot. You find scalar plot is full bullshit. So you're gonna fit the data set with a line and say this is a regression line, okay? And this regression line is determined without point what? A, B, C. And we're gonna add a point each time to study how it affects what? How it affects the regression line, okay? The first case, when you with or without A, okay? You don't have B, you don't have C. You have only A. Now, this is full bullshit scalar plot. This is best pretty line. And when you add A to the graph, how are you gonna affect the regression line? The answer is what? Little change, almost no change in regression line. And therefore, a big prediction error in A. And why is that? Look at here. When you add A to the data set. Now, the idea of what? The regression line is try to minimize the overall prediction error. So this line can move up. But can it move up to here? Of course not. If it move to here, then every point inside the scalar plot have what? Big prediction error. Is that clear? So you cannot move towards it. Since you consider overall prediction error, this one can move only a little bit, almost no move. Is that clear? Therefore, the point to the line has a big prediction error. We call what? A big prediction error, or you say residual. This is impact with A or without A. Now, second one, with or without B. Okay, look at second picture. With or without B. With or without B. Little change in regression again. Look at here. This line is actually very close to what? Regression line already. Am I correct? You don't have A, you don't have C. You add B. What happened to the line? Well, it just changed a little bit. Almost no change. Is that okay? Because the point is what? Very close to regression line. So little change in regression. So both A and B are not inferential because no change in regression line. Is that okay? Almost no change. Now, the one is inferential is the last one, okay? With or without C. You don't have A, you don't have a B, you have only C. When you add C, what happened? The line will be attracted towards C to minimize what? The vertical distance to C. Are you with me? This is very much feasible. Why it's feasible? Let me explain to you, okay? You can move towards what? Move towards the point. And that's feasible. Why it's feasible? Before a point is here, okay? You may say, well, Scott, if you rotate towards what? C. Huh? The distance will be, original is here. Now it's what? Increase the vertical distance. But you don't worry about it because the other side, this one will be minimized. Before it's what? To here. Now it's only to here. It's shorter. Is that okay? The one increase compensate by what? Its counterparts. Same thing here. A point here, if you rotate to here, it looks like the distance to the line become bigger. But the point on here, the distance become what? Shorter. Is that okay? So you don't need to worry about line inside what? The football shape. All you need to worry about is the line that close to C that minimize the vertical distance to C. Is that okay? People may say, well, Scott, why don't you use argument to the point A? Well, as you can see, regression line always goes through what? The center. Are you with me? It's like a fixed center. You cannot change the center. So by rotating the line, you cannot change what? You cannot change the vertical distance. Is that okay? But C is different story. By rotating it, you can minimize it. Is that okay? But not A, because regression line, remember regression line always goes through what? Goes through the center. It's like this point is fixed. You cannot change this point. You can only rotate like this. Is that okay? So vertical distance won't change. You understand what I'm saying? So let's look at the bottom. With or without C, big change in regression line because you rotate it. Make the line close to what? To C. Okay? And since point C will attract the line towards it, slope change means what? The way how you rotate Y to X also change. Is that okay? That's why it's what? It's inferential. Is that okay? So in this picture, in this given picture, A, B are not inferential. Only C is inferential. Is that okay? So regression usually only what? Outlier in what? X direction is influential. But in correlation, both what? X and Y outliers, they affect average X, average Y, standard deviation X, standard deviation Y. So in both directions, they are considered what? Influential. Is that okay?